Learn where to find order numbers for S7300 modules. Here's a picture of an S7300 rack. Let's locate the order numbers for building a hardware configuration or ordering replacement parts. The first module is a 24-volt, 5-amp power supply. The model number is PS307. S7300 order numbers are located on the bottom of the door, and the order number is 307-1EA00-0AA0. Next is a Profinet CPU model 315-2PNDP with order number 315-2EH14-0AB0. If the door is missing or the order number has become unreadable, remove the module and look on the side. 6ES7 is part of the ordering number, but is insignificant for locating in the hardware configuration catalog. With the CPU, you will also need the first 2 digits of the firmware version. This is typically located under the door at the bottom of the module. This CPU's firmware version is 3.2.6. When we're looking for the order number in the hardware catalog, we only need to know that it is version 3.2. Next is a 32-bit digital input module. The order number is 321-1BL00-0AA0. Here's a special simulator module. The order number is 374-2XH01-0AA0. You will not find this order number in the hardware catalog. Instead, you substitute a real module order number for what the card is simulating. You will not use this module in a real-world application. However, it requires no wiring and is a great module to have in a test rack. In the center of the module is a slotted switch. When the switch is turned down, the module will function as a 16-input module, and all 16 switches will work. When the switch is turned to the center position, the module will function as 8 input and 8 output. The bottom 8 bits will be switches, and the top 8 bits will be LEDs. When the switch is turned to the uppermost position, as pictured here, the module will function as 16 outputs, and only the LEDs will work. Next is an 8-input, 8-output module with order number 323-1BH01-0AA0. The last module in this rack is a 2-channel analog input with order number 331-7KB02-0AB0. It's worth mentioning that if you open the signal module's door, you'll find a wiring diagram on the door's back panel. As the final step, let's log each model number and order number for use in a later hardware configuration. Let's build a hardware configuration for an S7300 main rack. Here's a main rack consisting of a 5-amp power supply, a 315 Profinet CPU, a 32-bit digital input module, a 16-bit digital output module, an 8-in, 8-out digital module, and a 2-channel analog input module. We will need the module's order numbers, and you can learn more about this in the video on finding S7300 order numbers. We'll use this chart with model numbers and order numbers to help us as we move along. Right-click on your project, insert a new object, SIMATIC 300 station. You may rename the station if you like. Let's call this one my_station. Double-click on My Station, then double-click on the hardware icon. Drop down the SIMATIC 300 list, drop down Rack 300, and double-click to insert a rail. Resize the windows as necessary. Drop down PS300. Highlight the first 5-amp power supply and check the order number in the lower right box. Looks like this is the one. So double-click to add to the rack. Drop down CPU 300. Drop down CPU 315-2PNDP and double-click the version number. The Ethernet dialog box opens. We'll change this address to 192.168.111.102 to match the network this CPU will be used on. Click OK. Slot 3 is reserved for a special interface module that's used to communicate from one main rack to a second-tier main rack. It is not common to see this used anymore because Profibus is typically used, so we'll move the highlight to slot 4. Drop down DI300. Select the first 32-bit 24-volt module and check the order number. This is the module we're looking for, so double-click to add it to the rack. Drop down DO300. Highlight the first 16-bit 24-volt module and check the order number. Continue down the list until you find the correct order number. It looks like this is the one. Double-click to add it to the rack. Drop down DO300 and search for the correct order number. Double-click to add it to the rack. Drop down AI300 and search for the order number. Double-click to add it to the rack. Click the Save and Compile button. This compiles the hardware configuration data and saves it in the project. In this video, you'll see how to parameterize digital hardware modules in the hardware configuration. To begin, select your station and double-click the hardware icon. The first module in this rack is a digital input 32-bit module. Double-click the module to open its properties. On the General tab, you can change the module's name if you wish. Click the Addresses tab. To change the module's address, first uncheck the System Default checkbox. Since this is a 32-bit card, the hardware configuration editor won't let you use an address unless the next 3 bytes after the beginning address are free. Let's change the beginning address to 100. The module will now occupy input bytes 100, 101, 102, and 103. You should not change the process image from OB1 unless you are sure what that entails. You can find out more about process images in the help file. Click OK. The next module in this rack is a 16-bit digital output module. Double-click to open its properties. You can also change the name here on the General tab if desired. Select the Addresses tab. Uncheck the System Default box, and we will change this address to 104. Since this module is 16 bits or 2 bytes, it will occupy the input bytes 104 and 105. Click OK. The next module in the rack is a digital 8-bit input, 8-bit output module. Double-click to open its properties. As with the other digital cards, you can change the name here on the General tab. Select the Addresses tab. Uncheck System Default for the input address. We will change the input address to 106. Uncheck System Default for the output card. We will change the output address to 106. So this card will occupy input byte 106 and output byte 106. Click OK. Parameterizing analog modules will be covered in a separate video. After changes have been made in the hardware configuration, be sure to save and compile and then download to the PLC. This concludes the video on parameterizing digital modules in the hardware configuration. In this video, you'll see how to parameterize an analog module in the hardware configuration. Select your station and double-click the hardware icon. Double-click the analog module to open its properties. To enable diagnostics, put a check in the box Diagnostic Interrupt. Then place a check in the Group Diagnostics box under each channel group that you want to report diagnostics. The first group covers the first two channels or inputs, 0 and 1. If any channel group is unused, you should deactivate it. Click the Measuring Type field to select the input signal for this channel group. The default measuring range is 4 to 20 milliamps, which is what we want. You will need to choose the measuring type for each channel group. For channels 4 and 5, the measuring type will be thermocouple. The measuring range will be type K. You can choose the interference frequency to protect against for each channel group. The checkbox Hardware Interrupt when limit exceeded allows you to set a high limit and low limit range for channel 0 and channel 2. If we were to set the high limit at 18 milliamps and the low limit at 6 milliamps, then if the signal goes below 6 milliamps or above 18 milliamps, the organization block OB40 will be called for. The user can program the desired action in OB40. More help can be found in the S7 help files. You can also change the module's address in the Addresses tab. Click OK to close the Properties box. After changes are made in the hardware configuration, be sure to save and compile and download to the PLC. Some hardware analog modules have to be set up to match these software settings before being installed on the rack. That is covered in a separate video. Parameterizing digital modules is also covered in a separate video. This concludes the video on parameterizing analog modules in the hardware configuration. This video shows the CPU Properties General tab in the Hardware Configuration Editor. With the Hardware Configuration open, double-click the CPU. The first tab of CPU Properties is the General tab. In the short description field, you will find the amount of high-speed or work memory, the time it takes to execute 1000 instructions, and information about communication protocol and interfaces. Whether multi-tier configuration and routing is supported, and the CPU's offline catalog firmware version are also shown. Here you give the CPU its name that is identified in the project structure and also downloads to the CPU. The optional plant designation field identifies parts of the plant according to their functions and conforms to the IEC 1346-1 standard. The optional local designation field identifies a measuring point or group of measuring points within a system, similar to identifying a street on a map. The IDs entered in either of these fields can be evaluated in the user program. Click the Help button for more information and a sample program. Click the Comment field. In the Comments field, you can enter a note that displays in the Hardware Configuration window. Click OK to close the CPU Properties. The CPU comment shows in the Details window comment field next to the CPU. Keep in mind that if CPU parameters are changed, the hardware configuration must be downloaded again. The other tabs of CPU Properties are discussed in separate videos. This concludes the video on CPU Properties General tab. Shows the CPU Properties Startup tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Startup tab. The preset configuration is the set of data blocks created when the hardware configuration has been saved and compiled. The actual configuration is the physical hardware system managed by the PLC controller or CPU. By default, there's a check in the box, Start up if preset configuration does not match actual configuration. If this box is unchecked and there's a configuration mismatch between the preset and actual, the CPU will switch to the stop mode. Typically, this box is left checked. With most S7-300 CPUs, such as this 315-2 PNDP, warm restart is the only option. What this means is that if the CPU is switched from stop to run or power is cycled, the CPU calls once for organization block OB100 and then the normal cyclic operation begins. The monitoring time field next to finished message with module is the amount of time that the modules in the central rack have to return a ready signal to the CPU. For example, if this value is changed to 500 milliseconds, then after 500 milliseconds, if the CPU did not get a ready signal from each module in the central rack, it would respond depending on the check mark in the startup if preset box is checked or not. After the CPU receives a ready signal from each module in the central rack, then the monitoring time next to transfer of parameters to modules is the amount of time for this CPU to transfer parameters to the modules in the central rack. If the modules do not receive the parameter transfer during this time, the CPU will respond according to the check mark in startup if preset box is checked. If the CPU has a Profibus DP master port, then this time will apply to the transfer of parameters to the Profibus DP modules also. Click OK when finished with the CPU properties. Keep in mind that if the CPU parameters are changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of the CPU properties are discussed in separate videos. This concludes the video on CPU Properties Startup tab. This video shows the CPU Properties Startup tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Startup tab. The preset configuration is the set of data blocks created when the hardware configuration has been saved and compiled. The actual configuration is the physical hardware system managed by the PLC controller or CPU. By default, there's a check in the box Startup if preset configuration does not match actual configuration. If this box is unchecked and there is a configuration mismatch between the preset and actual, the CPU will switch to the stop mode. Typically, this box is left checked. With most S7-300 CPUs, such as this 315-2 PNDP, warm restart is the only option. What this means is that if the CPU is switched from stop to run or power is cycled, the CPU calls once for organization block OB100 and then the normal cyclic operation begins. The monitoring time field next to finished message with module is the amount of time that the modules in the central rack have to return a ready signal to the CPU. For example, if this value is changed to 500 milliseconds, then after 500 milliseconds, if the CPU did not get a ready signal from each module in the central rack, it would respond depending on the check mark in the startup if preset box is checked or not. After the CPU receives a ready signal from each module in the central rack, then the monitoring time next to transfer of parameters to modules is the amount of time for this CPU to transfer parameters to the modules in the central rack. If the modules do not receive the parameter transfer during this time, the CPU will respond according to the check mark in startup if preset box is checked. If the CPU has a Profibus DP master port, then this time will apply to the transfer of parameters to the Profibus DP modules also. Click OK when finished with the CPU properties. Keep in mind that if the CPU parameters are changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of the CPU properties are discussed in separate videos. This concludes the video on CPU Properties Startup tab. This video shows the CPU Properties Diagnostics Clock tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Diagnostics Clock tab. By default, the box Report Cause of Stop tells the CPU to write a diagnostics message in the diagnostics buffer if the CPU goes to stop. Leave this box checked unless you do not want CPU stop messages written into the diagnostics buffer. The number listed in the number of messages in the diagnostics buffer field determines the number of messages which can be viewed in the diagnostics buffer while online with the CPU in run. All messages can be seen when the CPU is in the stop mode. Time synchronization can be set in the PLC internally, on the multi-point interface or MPI network externally, and with a correction factor in milliseconds. The PLC can be set as a master where the CPU synchronizes other clocks, or as a slave where the CPU is synchronized by other clocks. The same settings apply to synchronization on the MPI network. Click OK when you're done parameterizing the CPU. Keep in mind that if the CPU parameters are changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of CPU properties are discussed in separate videos. This concludes a video on CPU Properties Diagnostics tab. This video shows the CPU Properties Protection tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Protection tab. The default setting is the radio button key switch setting, which means the PLC is operated with the stop run switch located on the front of the PLC. With the right protection radio button, you can assign a password with up to 8 characters. The password will be required to download to the PLC. With the read-write protection radio button, you can assign a password which will be required to upload or download to the PLC. For instance, if you wanted to copy a block from online to offline or upload a station, the password would be required. Monitoring blocks is still allowed. Be careful though, if the password is lost or forgotten, the micro memory card will have to be deleted or reformatted. For older CPUs that have the removable key switch on the front, the checkbox "Can be bypassed with password" allows the user to enter a password and access the CPU even if the key switch has been removed. For the write and read-write protection levels, there's also a way in Semantic Manager to enter a password that is good for the remaining session, that is until Semantic Manager is closed. Click the Help button for more details. Click OK when you are finished parameterizing the CPU. Keep in mind that if the CPU parameters are changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of the CPU properties are discussed in separate videos. This concludes the video on CPU Properties Protection tab. This video shows the CPU Properties Communication tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Communications tab. This is a place where you can reserve communication resources. By default, there are 16 available connections. One connection is reserved for a computer or PG, and one is reserved for an HMI operator panel or OP. Additional devices or communication blocks in the code take the remaining connections on a first-come, first-served basis. Having a reservation guarantees that a connection will be available for the resource that is trying to connect. S7 basic communication is carried out over the multi-point interface or MPI network. Reserved connections for communication blocks, such as for client-server communication, guarantee a connection will be available. S7 basic communication is typically not reserved, but allowed to take up resources as they are needed and release them when they are done. The S7 communication is populated from connections made in the NetPro program. When you are done setting CPU parameters, click OK to close the CPU Properties box. After CPU parameters have been changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Communication tab. This video shows the CPU Properties web tab in the hardware configuration. With the hardware configuration opened, double-click the CPU to open its properties. The web tab only shows if you are using a Profinet CPU. Click on the web tab. Select Enable Web Server in order to access the CPU from a web browser. When the hardware configuration is saved and compiled and downloaded, this will download web pages to the CPU. You will see a message advising that you may make the CPU vulnerable to outside access and that you should take necessary security precautions. There's also a link for help on security. Click OK if you want to continue. Select up to 2 languages for the web pages. If you want the web page to auto-update, check the Activate box under Auto-Update. Set an update time interval. We will change the update time to 5 seconds. There are 16 message classes associated with Report System Error message text. By default, all 16 classes will display. You can select which text or classes should display on the web pages. See Help on Message Classes and Report System Error for more details. If you click the Add button, you can add password-protected users and access rights to the PLC web pages. When you're finished setting CPU parameters, click OK to close the Properties window. After CPU parameters have been changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties web tab. This video shows the CPU Properties Cycle Clock Memory tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Cycle Clock Memory tab. The first field that can be edited is the Scan Cycle Monitoring Time or Watchdog Timer. By default, the max scan cycle time is set at 150 milliseconds. This means from the time that OB1 begins until the scan is completed and OB1 begins again, you have 150 milliseconds. If the scan time is exceeded, OB80 is called for. If it has been downloaded to the CPU, the watchdog time will be temporarily expanded. If OB80 is not in the CPU, the mode will be switched to stop. You can reduce this number or expand this number up to 6,000 milliseconds. When communication is carried out, for example between 2 CPUs, the scan time is increased. The scan cycle load from communication percent influences the amount of time that the scan can be increased as a result of communications. If you are doing heavy communications in your project, click the Help button to see the communication load formula and more details about setting this field. Placing a check in the box Prioritized OCM Communication will speed up communication between the HMI and CPU, but does slightly increase the scan time. If the CPU does not support this function, the box is grayed out. The default size of the input and output process images, in other words how many IOs you can have, is 128 bytes or 1024 bits by default. On newer CPUs such as this one, the size of the process images can be expanded up to 2048 bytes or 16,384 bits. Let's increase this value to 256 bytes. We will also change the output image size to be 256 bytes. The default for OB85 call-up at I/O access error is no OB85 call-up. The optional organization block 85 can be programmed and downloaded for a response if an I/O access error occurs during the update of the input or output process image. If you wish to program an OB85 call, it is recommended that you not choose at each individual access, or OB85 will be called every scan for every update of the images, and the scan cycle time will be increased. Instead, choose only for incoming and outgoing errors. Then OB85 will only be called if there's an error during the updating of the input and output images. The clock memory is the allocation of 1 byte of the M memory area. Let's assign byte 10. Once a byte is assigned and the hardware configuration downloaded, each bit of the byte begins cycling on and off at the rate shown in the table. In the code example, memory bit 10.3 will cause output Q5.0 to flash at a frequency of 2 Hz. Or said another way, the bit will be true for 0.25 seconds and false for 0.25 seconds for a total period of 0.5 seconds. When you're finished setting CPU parameters, click OK to close the Properties window. After CPU parameters have been changed, the hardware configuration must be saved and compiled and downloaded again. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Cycle Clock Memory tab. This video shows the CPU Properties Retentive Memory tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Retentive Memory tab. By default, the first 16 memory bytes, that is memory byte 0 through memory byte 15, retain their values through a change from stop to run of the CPU mode switch or a power cycle. Change the value to 0 if no memory bytes are to be retained. Standard somatic timers do not retain their values by default. The first 8 counters, counter 0 through counter 7, retain their values by default. Change this value to 0 if you do not want any counters to be retentive. Selecting a value such as 50 would mean that memory bytes 0 through 49 would retain their values through a stop to run of the mode switch or a power cycle. Enter the number of standard timers and standard counters whose values you want to retain in memory during a stop to run or power cycle. We will assign some numbers for demonstration purposes. Current CPUs use micro memory cards, and data blocks are by default automatically retentive. For older CPUs that relied on batteries, the data block's beginning byte address and number of bytes could be marked retentive. Click OK to close the properties. After changing the CPU parameters, the hardware configuration must be saved and compiled and downloaded. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Retentive Memory tab. This video shows the CPU Properties Interrupts tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Interrupts tab. This tab shows the available organization blocks for hardware interrupts, time delay interrupts, master-slave Profibus DPV1, acyclic data exchange interrupts, and asynchronous hardware-related error interrupts. If several organization blocks are called at the same time, the priority number determines the execution order. The higher the number, the earlier the block runs. For example, if OB40 with priority 16 has just been launched, but there's a Profibus or Profinet network failure, OB86 with priority 26 would interrupt and execute. While the priority numbers can be changed, it is recommended that you leave them at the default settings. Further explanations and examples of the organization blocks and their use are covered in separate videos. Click OK to close CPU properties. After changing the CPU parameters, the hardware configuration must be saved and compiled and downloaded. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Interrupts tab. This video shows the CPU Properties Time of Day Interrupt tabs in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click on the Time of Day Interrupts tab. For the S7300 processors, OB10 is the only available time of day interrupt. The block is activated from the hardware configuration, but programmed in the programming editor. The block can be set to execute once on a particular date and time, or can be set to execute every minute, every hour, day, week, month, end of month, or year. For example, we could set this block to run every minute. Beginning on April 29th of 2013 at 8 a.m. in the morning. An example of programming OB10 and other organization blocks are shown in separate videos. Click OK when you're finished with CPU properties. After changing the CPU parameters, the hardware configuration must be saved and compiled and downloaded. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Time of Day Interrupts tab. This video shows the CPU Properties Cyclic Interrupts tab in the hardware configuration. With the hardware configuration open, double-click the CPU to open its properties. Click the Cyclic Interrupts tab. For this CPU, organization blocks 32 through 35 are available as cyclic interrupts. Organization blocks are created in Somatic Manager and programmed in the programming editor, then downloaded to the PLC. By default, OB35 is called every 100 milliseconds, OB34 every 200 milliseconds, OB33 every half second, and OB32 every second. Organization blocks with higher priority numbers run first. You can also input a millisecond time in the phase offset field to offset blocks that are called at the same time. For instance, if all four of these blocks are programmed and downloaded, at the 1 second mark, OB32 through 35 will be called at the same time. Using a phase offset will delay the start time by the number of milliseconds input. The execution times can be changed. For instance, we could set OB35 to execute every 75 milliseconds. And OB32 to execute every 750 milliseconds. For demonstration purposes, we will enter an offset of 10 milliseconds for OB32. Explanations and examples of organization blocks and their use are covered in separate videos. When you're finished setting the CPU's parameters, click OK. After changing the CPU parameters, the hardware configuration must be saved and compiled and downloaded. The other tabs of CPU properties are discussed in separate videos. This concludes the video on CPU Properties Cyclic Interrupts tab.
This video shows how to update the hardware configuration after a module has been changed out on the physical rack. This 2-channel analog input module with order number 331-7KB02-AB0 is being replaced with an 8-channel analog input module with order number 331-7KF02-AB0. To begin, select your station and double-click Hardware. Double-click the analog module to open its properties. If the existing module's name is different than the default, be sure to record the name. Select the Address tab. Record the existing module's address. Select the Inputs tab. Record these settings before replacing the module. Let's find the new module. Drop down Somatic 300. Drop down Signal Module 300. Drop down AI 300. Begin searching in the Analog Input 8 section for the order number 331-7KF02-0AB0. After highlighting a module, check the order number in the lower right window until you find the one you're searching for. Here is the module we're looking for. First, try to drag the new module on top of the existing module. This will copy the existing module's settings to the new module. If the module cannot be swapped, a circle with a line through it will show. In this case, you will have to delete the existing module and use your recorded data to parameterize the new module. Double-click to open the new analog module's properties. You can rename the module on the General tab. Select the Address tab. The address is the same as before, so click the Inputs tab. The first two channels, 0 and 1, have the copied settings from the existing 2-channel analog module. You will need to set the parameters for the remaining 6 channels or inputs. You can find more information about setting the measuring type, measuring range, and interference frequency in the video Setting Analog Module Parameters. Once you have set the parameters, click OK. Save and compile the hardware configuration. Since the module has already been swapped in the hardware, we will download the configuration to the PLC. Some analog modules, such as the 8-channel input module, have to be physically configured by correctly placing jumper chips on the side of the module. You can see a demonstration of this by watching the video Setting the Measuring Ranges of an Analog Module. This concludes the video on how to update the hardware configuration after a module change in the rack. This video shows you how to combine ET200S pairs of 4-bit digital modules on separate bytes into a single byte. First, select your station and double-click Hardware. In the hardware configuration, select the ET200S station. In this ET200S station, all the digital inputs and output modules are assigned to separate bytes. The first 2 digital input modules are assigned to bytes 4 and 5. Let's combine them into a single byte. First, we have to set the address. Double-click on the first digital input module. Select the Address tab. We will set the input address to 10. Click OK. With the first digital input module highlighted, hold down the Shift key and click on the second digital input module. Click the Pack Address button. Both of the modules have now been combined into a single byte with input address 10. Let's combine the first 2 digital output cards. Double-click the first digital output card address byte 0. Choose the Address tab and set the output address to 10. Click OK. With the first digital output module highlighted, hold down the Shift key and click on the second module. Click the Pack Address button. In the 2 previous examples, we set the address first and then pack the bytes. This time let's pack the bytes first and then set the address. Highlight the first digital input module, address byte 6. While holding down the Shift key, click on the second digital module, address byte 9. Click the Pack Address button. Both modules have been combined into byte 6. Double-click the first DI module, address byte 6. Click the Address tab and change the input address to 11. Click OK. Let's do the final 2 digital output modules, currently bytes 2 and 3. Highlight the first digital output module, address byte 2. Hold the Shift key and select the second digital output module, address byte 3. Click the Pack Address button. The 2 modules have been combined into byte 2. Double-click on the first DO output module, address byte 2. Click on the Address tab and change the output address to 11. Now the first set of digital input and output modules have been combined to input and output address 10, and the second set of digital input and output modules have been combined to input and output address 11. Click the Save and Compile button to save the changes and get them ready for downloading to the PLC station. After making changes to the hardware configuration, you'll need to download it to the PLC. This concludes the video on combining ET200S pairs for 4-bit digital modules on separate bytes into a single byte.
Here you will learn several methods to download an S7 station and blocks. In the first method, we will download the hardware station and all the blocks at the same time. Here are several important notes. First, the CPU will be placed in the stop mode during the hardware station download. Second, to do this full station download from Simatic Manager, the CPU's address must be the same as the address in the hardware configuration, or this will not work. Third, the PG-PC interface of Simatic Manager must be set to agree with how you are connected to the PLC. If you need help with setting the interface, watch the video on setting PG-PC interface. Click on your station. Click the download button. Click Yes to the System Data Replacement message. If there are any differences in the online and offline data, it will be flagged with a yellow triangle. Here the CPU name in the project is different than what's in the CPU. Click OK to continue downloading the offline station and overwrite the online data. After the hardware station is downloaded, all the blocks will be downloaded as well. If the blocks already exist, you'll be prompted with an overwrite message. In this demonstration, there are no blocks in the CPU, so the blocks load with no warnings. The CPU was placed in the stop mode during the hardware station part of the download. Click Yes to restart the CPU and put it back in the run mode. If your hardware station was up to date, but you wanted to do a blocks download, click the blocks folder and click the download button. A caution message tells you to check the sequence of the blocks for correct functions. By doing a full blocks folder download, it is possible that calling blocks could be loaded before the blocks that are being called. If this happens, the CPU will go to stop. If you have doubts about the order, it would be better to select the blocks individually and download them. For this demonstration, we'll go ahead and replace all the blocks, so click OK. Since the blocks existed, we will click All to download and overwrite all the blocks. The System Data folder is part of the Blocks folder and contains the hardware configuration. After the blocks are downloaded, you are asked if you want to download the system data. If the hardware configuration is up to date, click No. Also, be aware that if you click Yes, the CPU will be set to stop while the hardware configuration loads. If you would like to download the hardware configuration alone, or if the CPU's address is different than what's in the hardware configuration, then open the hardware configuration editor and download from there. Click on your station, then double-click Hardware. Click the Download button. The CPU listed in the hardware configuration will appear as the target module to download to. Click OK. Because the IP address in the offline hardware configuration matches the address of the CPU, the download window sees the CPU and displays the MAC address and module type as shown in this window. If the MAC address and module type information were missing, the download would be unsuccessful. You can poll the network to see what nodes or stations are accessible by clicking the View button. It is only necessary to do this if your module type is not showing. To demonstrate, we'll poll the network. If you are trying to replace the CPU's address, you could select the CPU from the accessible nodes list and continue with the download. After the download, the CPU's address would be changed to the address in the hardware configuration. Click OK to continue with the download. Click OK to the stop message. Click Yes to restart the CPU and put it in run mode. The download is complete, so close the window. The last method shows how to individually download blocks from the Blocks folder. Select the block or blocks that you want to download. A special note here is that the blocks will download in the order that you select them. So if you have a block that is being called, select it before the block that is doing the calling, and click the download button. If the block or blocks already exist, you'll be prompted to overwrite them. This concludes methods for hardware station and blocks download.
In this video, you will see how to export an S7 hardware configuration from the Simatic Hardware Configuration Editor. From the Simatic Manager, double-click the hardware icon. In the Hardware Configuration Editor, select the Station menu. Choose Export. In the export window that pops up, browse to a file storage location. We will store this one on the D drive in a folder named Archives. Change the name of the file here if desired. We will leave this one with the suggested file name MyStation. Click Open. By default, symbols and communication networks or subnets will be included in the export file. If you put a check in the box, Export Default Values, then in addition to the changed parameters, default unchanged parameters will be exported. By default, format is set to readable. This means the data will be exported in strings. If compact is chosen, then the data is exported in hexadecimal. Click Save. The file has been exported. Close the Hardware Configuration Editor. Open Windows Explorer. Here on the D drive, in the Archives folder, is the exported hardware configuration file, MyStation, which is a CFG extension. You can see how to import a CFG hardware configuration file by watching the video Import S7 Hardware Configuration. This concludes the video on exporting an S7 hardware configuration. This video shows how to import an S7 hardware configuration from an exported CFG file. Let's first create a project. In Simatic Manager, select the File menu. Choose New. We will name this Test Project. Click OK. Right-click on the newly created test project. Choose Insert New Object. Choose Simatic 300 Station. Double-click the Simatic 300 Station icon. Only a hardware station container is created. There's no CPU, no program folder, and no blocks folder. Double-click Hardware. In the Hardware Configuration Editor, select the Station menu. Choose Import. Navigate to where the CFG file is stored. The file we're looking for is stored on the D drive in the Archives folder. The hardware configuration that we will import is called MyStation CFG. Double-click the file. After the data is imported, you'll be asked if you want to save it. Click Yes. Let's maximize the Hardware Configuration Editor. The complete hardware configuration has been imported, including stations, communication networks or subnets, all parameters, device names, and even comments. Click Save and Compile to add this data to the project and prepare it for downloading. Close the Hardware Configuration Editor. The hardware station container has now been populated with CPU, the S7 program folder, which also contains the symbol table, the sources folder, and the blocks folder. This concludes the video on programming an S7 hardware configuration from a CFG file. In this video, you will see how to use the Address Overview tool in the Simatic Hardware Configuration Editor. Select your station and double-click Hardware. Of course, you can highlight a station in the Overview window to see the module's addresses in the Details window. To see the address overview for all devices and modules in all stations and subnets, select the View menu. Choose Address Overview. Let's stretch the window for a better view. By default, both inputs and outputs will be displayed. You can filter by removing a check from the box. In the Type field, you see if the device or module is input or output. Next is the beginning address, followed by the end address. Then, what the module or device is, followed by the process image the device is assigned to, such as OB1. If the device is on a Profibus, then DP network with DP address is in parentheses, followed by Profinet PN network and the device number in parentheses. or is the device part of the foundation field bus system, followed by the number of devices in parentheses. Next, what rack is it in? What slot is it in? And if it is an interface module or an interface port, and which module slot or port number it is. If you put a check in the box next to address gaps, the address range gaps will be shown. This concludes the video on the address overview tool in the Somatic Hardware Configuration Editor.
Here you will see several ways to arrange the station layout in Somatic Hardware Configuration Editor. First, select your station and double-click Hardware. The first way to arrange the stations is to let the Hardware Configuration Editor do it for you. Select the View menu and choose Auto Arrange. You get a warning that the current arrangement will be lost. Click Yes if you want to continue. The Hardware Configuration Editor then rearranges the stations. The second method is manual. You arrange the stations by dragging them around. When you are finished with the arrangement, click the Window menu and choose Save Settings. This concludes the video on arranging stations in the Somatic Hardware Configuration Editor. In this video, you'll see how to create your own custom hardware catalog profile. From your S7 project, select your station and double-click Hardware. In the Hardware Configuration Editor, select the Options menu. Choose Edit Catalog Profile and enlarge the window for a better view. To begin creating your profile, pick an element such as the power supply for the S7-300. Widen the columns so you can see the order numbers. Let's pick the bottom 5 amp power supply, order number 6ES7 307-1EA01-0AA0 and drag it to the bottom window. Now select the CPU 300. Drop down the Profinet CPU 315-2PNDP. Highlight the order number. We will choose 6ES7 315-2EH14-0AB0. Select the version number, in our case version 3.2, and drag it to the lower window. Drop down the Signal Module 300 folder. Let's choose Digital Input Module 300. We will choose the Digital Input 32-bit 24-volt module whose order number is 6ES7 321-1BL00-0AA0 and drag it to the bottom window. Let's select a digital output module. We will select the digital output 16-bit 24-volt 0.5 amp module with order number 6ES7 322-1BH01-0AA0 and drag it to the lower window. Next, we will select Digital Input Digital Output 300. We will choose the Digital Input 8 Digital Output 8 with order number 6ES7 323-1BH01-0AA0 and drag it to the lower window. Now let's select an analog input module. Choose the analog input 2 channel with order number 6ES7 331-7KB02 0AB0 and drag it to the lower window. We will now close the SIMATIC 300 folder and open the Profinet IO folder. Drop down Network Components. Let's select a Scalent switch. Drop down Scalent X200. Drop down Scalent X208 and select the Scalent switch 6GK5 208-0BA10-2AA3. Choose version 4.2 and drag it to the lower window. Drop down the I/O folder. Drop down ET200S. Interface modules such as the IM151-3 have a set of subfolders containing compatible modules in them. So for this element, we will drag down the entire IM151-3 collection from the left window instead of a single element from the right window. The profile is now complete. Let's save it. We will name it My Profile. Click OK. Close the profile window. In the Hardware Configuration Editor, drop down the Profiles field. Choose My Profile. Here's the profile we just created. Drop down next to the IM151-3. Here are the folders containing the modules that are compatible with the IM151-3. This concludes the video on how to make a custom hardware profile. In this video, you'll see how to monitor variables from the Hardware Configuration Editor. To begin, select your station and double-click Hardware. This hardware configuration has several I/O modules. Right-click on the first digital input 32-bit module and choose Monitor Modify. For a single scan update, click the Status Value button. To update cyclically, click the checkbox next to Monitor. Click the Trigger button. By default, monitoring is done at the beginning of the scan cycle, which is what you want for inputs since they are read in at the beginning of the scan. The trigger condition updates every cycle by default. You may also choose to monitor at the end of the scan cycle, which would be better for outputs, and lastly, you can monitor when the CPU transitions to stop. If you change the trigger condition to once, then when you check the monitor box, updating will only occur for one cycle instead of every cycle. If you place a check in the box I/O display, then the value of the bytes is shown in hexadecimal format. Close the Monitor Modify window. Right-click the digital output module. Choose Monitor Modify again. Put a check in the monitor box. To see if any forces are taking place, press the F5 key. Line 3, Q4.2 is being forced from a force table as indicated by the red F. You can learn how to view a force table and how to start and stop forcing in the video on forcing I/O. Close the Monitor Modify window. Right-click the analog input module and choose Monitor Modify. Put a check in the monitor box. The two analog input channels are shown in hexadecimal values. You cannot change the display format here in the hardware configuration. You can, however, view and change to other formats in a variable table. You can see more by watching the video Create and Monitor Variables using a variable table. Close the Monitor Modify window. Click on the ET200S station. In the Details window, right-click on the 4-bit digital input module. Choose Monitor Modify. Select Monitor, and you see the status of the 4 input bits. Check the box I/O display to see the byte shown in hex form. Close the Monitor Modify window. How to modify I/O values is shown in a separate video. This concludes the video on how to monitor I/O from the SIMATIC Hardware Configuration Editor. In this video, you'll see how to monitor variables from the Hardware Configuration Editor. To begin, select your station and double-click Hardware. This hardware configuration has several I/O modules. Right-click on the first digital input 32-bit module and choose Monitor Modify. For a single scan update, click the Status Value button. To update cyclically, click the checkbox next to Monitor. Click the Trigger button. By default, monitoring is done at the beginning of the scan cycle, which is what you want for inputs since they are read in at the beginning of the scan. The trigger condition updates every cycle by default. You may also choose to monitor at the end of the scan cycle, which would be better for outputs, and lastly, you can monitor when the CPU transitions to stop. If you change the trigger condition to once, then when you check the monitor box, updating will only occur for one cycle instead of every cycle. If you place a check in the box I/O display, then the value of the bytes is shown in hexadecimal format. Close the Monitor Modify window. Right-click the Digital Output module. Choose Monitor Modify again. Put a check in the monitor box. To see if any forces are taking place, press the F5 key. Line 3, Q4.2, is being forced from a force table as indicated by the red F. You can learn how to view a force table and how to start and stop forcing in the video on forcing I/O. Close the Monitor Modify window. Right-click the Analog Input module and choose Monitor Modify. Put a check in the monitor box. The two analog input channels are shown in hexadecimal values. You cannot change the display format here in the hardware configuration. You can, however, view and change to other formats in a variable table. You can see more by watching the video Create and Monitor Variables using a variable table. Close the Monitor Modify window. Click on the ET200S station. In the Details window, right-click on the 4-bit digital input module. Choose Monitor Modify. Select Monitor, and you see the status of the 4 input bits. Check the box I/O display to see the bytes shown in hex form. Close the Monitor Modify window. How to modify I/O values is shown in a separate video. This concludes the video on how to monitor I/O from the Somatic Hardware Configuration Editor.
This video demonstrates how to install a GSD file into the Hardware Configuration Catalog. The term GSD means General Station Description and is a software configuration file used to parameterize a hardware device. Most manufacturers offer GSD files for their automation hardware devices. After you have downloaded a GSD file, open Windows Explorer. Navigate to the folder that holds the GSD file. We will install a Siemens 317T CPU GSD file. The file may be compressed and need to be extracted. Choose a destination to extract the file to and click Extract. Now you can close the file extraction window and close Windows Explorer. Open Somatic Manager, select your station in the left window and double-click the hardware icon. When the Hardware Configuration Editor opens, select the Options menu. Then choose Install GSD File. Click Browse and navigate to the GSD extracted file location. Select the GSD folder and click OK. The folder may contain several language descriptions. For instance, the E in GSE means English, F, French, G, German, I, Italian, S, Spanish. Highlight the GSE file and click Install. You'll get a caution telling you the installation cannot be undone. Click Yes. You should get a success message after the installation. Click OK. Select the search text box. Enter the device GSD file description, 317T. Then click the Search Down button. you will find that most GSD files involving Profibus will be stored under Profibus DP Additional Field Devices. Since this is a PLC, it is stored under the PLC folder. This GSD file is now ready to be used in a hardware configuration. This concludes the video on installing a GSD file into the SIMATIC Hardware Configuration Catalog. This video demonstrates how to update the SIMATIC Hardware Configuration Catalog. To begin, select your station. In the Hardware Configuration Editor, select the Options menu. Choose Install Hardware Updates. The first time you run the Update tool, you will see a message telling you that a directory has to be set for hardware updates either locally or on a network, and asks if you want to create that directory now. Click OK. You will need an internet connection to download the updates. The default settings are to show the updates, ask for confirmation before installing, and use a browser. Click OK. Click Yes to the Create Folder message. The default is to download the updates from the internet. If you have downloaded them from another machine, you can then choose Copy from Disk. Click the Execute button. If updates are available, they will show in the list. Uncheck any that you do not wish to download. Then click the Download button. The check is removed from the box as each file is downloaded. You will see a Download Completed message after all the updates have been downloaded. Click OK. Then click the Close button. Updates that are not installed will have a check in the box and a No under the Installed column. Any updates that are incompatible will not be checked for installation. Remove the check marks if there are any updates that you do not want to install. Then click the Install button. You will see a message telling you the installation cannot be undone. Click Yes if you want to continue. A message warns that all Step 7 applications have to be closed. The tool asks if you want it to close the applications for you. Click Yes. The updates get installed into the Hardware Configuration Catalog. After the installation, you should see a success message. Click OK. Your Hardware Configuration Catalog is now up to date and ready to use. And that concludes this video.
This video shows how to find online manuals directly from the SIMATIC Hardware Configuration Editor. Begin by selecting your station. Then double-click Hardware. You must be connected to the internet to proceed. Let's see what manuals are available for the CPU. Right-click the CPU. Choose Find Manual. A number of manuals are available. Let's take a look at the S7300 instruction list for S7300 CPUs. Click the link. You have a choice to display or download the manual. For this demonstration, we will choose Display. Let's take a quick look inside. How about address identifiers and parameter ranges? This page shows the I/O address ranges for the different CPUs. Let's click on the subject status word on the left side. This page shows the details of the status word in the S7300 CPU. Let's close this manual. Also close the web page. Let's check out the manual for the analog input module. Right-click on the AI module and choose Find Manual. An S7300 module data manual is found. Let's take a look. Again, we will choose to display the document. Select Analog Modules on the left side. We will click on the module with part number 6ES7331-7KB02-0AB0 since that is the order number we have in the hardware configuration. Let's take a look at measuring types and measuring ranges. Shown here are the different types of measurement signals, measuring ranges, and measuring range module settings. Let's close this manual. Close the web page. Let's look at one final example. On the Profinet network, right-click on the switch and choose Find Manual again. Let's take a look at the configuration manual for Scalence X200 series switches. Choose to display once again. Let's look at the topic Assignment of an IP address. The details for assigning an IP address to a Scalent's X200 series switch begins here. In this video, you have seen 3 demonstrations of how to find Siemens manuals offered for specific hardware configuration devices using a link directly from the Simatic Hardware Configuration Editor. Keep in mind that you must have an internet connection to access the manuals on the web. And that concludes this video. This video demonstrates how to access Siemens device-specific support directly from the Hardware Configuration Editor. To begin, select your station and double-click Hardware. You will need an internet connection to access the websites. Let's check out the CPU first. Right-click the CPU and choose Product Support Information. This FAQ talks about what information is entered in the diagnostics buffer of the CPU. Click the link. Related links are shown at the top of the page in addition to the present article. Page. Let's check out support for this Digital Input 8, Digital Output 8 module. Right-click on the DIDO module. Choose Product Support Information. The Product Information tab shows product description, version release, product lifecycle, and links to updates, FAQs, and manuals. Click the Entries tab. Here you can find certificates, FAQs, and manuals. Click the Technical CAX Data tab. This tab contains technical data about the module. Close the web page. For a final demonstration, let's right-click on the ET200S station. Choose Product Support Information once again. Updates, downloads, FAQs, and manuals are available for this ET200S interface module. Let's download the operating system update. Scroll down the page. Here's a firmware version update to version 7.0.5. Click the .exe file to download. Save the file. Choose a storage location and then click the Save button. Let's open the folder. Here is the ET200S interface module's firmware zip file. The actual execution of the firmware update to the module is shown in a separate video. This concludes finding support directly from the Hardware Configuration Editor.